Hi, 12. In this video, we're going to go through the stationary points and increasing and decreasing functions. So just finding the questions. Here we go. So stationary points. Of course, we know that when we are considering a curve, we've got the gradient of the tangent at that point, positive gradient. We've got the gradient of the tangent at that point. That's a negative gradient. However, there are some special points for when that tangent is horizontal. So of course, for this function, we've got one there and we've got one there. So they are, of course, significant because they are telling us very distinct points about the curve. When the curve is kind of going from an increasing function, so I can see from there to there, the curve is increasing. And then you get to the maximum point, and then from there to there, the curve is decreasing. And then we get to the minimum point, and then afterwards it's increasing. So two things in particular we can find from stationary points. Firstly, when the gradient itself is zero, obviously that's important kind of in a lot of contexts, but also actually it pinpoints very well when the curve is increasing and when the curve is decreasing. So that's why these two sections often come together within the question. Either way, we always start by finding our dy dx. So this curve here, x squared minus 32 root x plus 20. The first thing to do, I suppose, would be to rewrite that root x as an x to the power of a half. Then I've got the 20. At the end, if I differentiate, I've got 2x minus 32 times a half is 16. I need to subtract 1 from the power to get negative a half, and then when I differentiate 20, that's 0. Now, we know that for a stationary point, so this is for a max and a min, we know that the gradient is equal to 0. So in particular, dy dx is equal to 0. So that means that I've got 2x minus 16 x to the negative a half being equal to 0. So 2x, well, we could put that over there on that side, divide both sides by 2. Now, I've kept this as a power of negative a half. My instinct actually would be to rewrite it. However, from this point here, hopefully you can see that if you multiply both sides by x to the half, that would get you x to the power of 0. Times that by x to the half, you would collect your x's together in one place. But as I said, I think my instinct would be to divide by the 2, but then I'm going to write that as x over x to the half, and then I can see just a little bit more easily. I'd multiply both sides by x to the half. So x to the power of 3 over 2 is equal to 8. If x to the power of 3 over 2 is equal to 8, then x is equal to 4. Because 4 to the power square root is 2, and then 2 cubed gets me an answer of 8. Okay, so that is the x value of my stationary point. Find the stationary point, I of course need to find the y value as well. So when x is equal to 4, I know that y is equal to, so I'm going to substitute it into there. 4 squared minus 32 times by root 4 plus 20. So it's going to be 16 minus 32 times by 2 minus 64 plus 20. So that's 36 minus 64 minus 28. So I know that the stationary point is at 4, negative 28. Determine the nature. So what we've got to do here is to find the second derivative. So if I go back to my function, if I go back to my dy dx, which is here, I need to differentiate that again. So we need d2y by dx squared. Differentiate again, I get 2. So this is a bit more awkward this time, so I'm going to write down the negative 16, and then I can think about differentiating x squared negative a half. Bring the power down, write the x, reduce the power by 1. 2 minus, well, actually, if I multiply negative 16 by negative a half, it will be plus 8 x to the power of negative 3 over 2. So we need to evaluate this at x equals 4. So remember, this is when our stationary point occurs. So I pop that into there, and remember the fact that you need to state. So if d2y by dx squared is greater than 0, then we've got a minimum. And if we have d2y by dx squared is less than 0, then we have got a maximum. And I think I can see already where this is going. Here, d2y by dx squared is equal to 2 plus 8 multiplied by x to the power of minus 3 over 2. So in particular, and if I write it like that, that's very obvious, isn't it? Because everything there is positive. But if I just go ahead and evaluate that, I'd have 8 over 8 there, which is equal to 3. And as 3 is greater than 0, I've got d2y by dx squared is greater than 0. So I have got this option here. Hence the point, where was it? 4, negative 28 is a minimum. Okay, moving on then. Let's just put that all on the next one. Can I? On the next page. So finding stationary point. So I am going to differentiate. So dy by dx is 4x cubed plus 32. I need dy dx equal to 0 for stationary point. So 4x cubed plus 32 is equal to 0. X cubed will be equal to negative 32 over 4. Negative 8. So if I take the cube root of that, I've got one stationary point, and that occurs when x is equal to negative 2. When x is equal to negative 2, then y is negative 2 to the power of 4 plus 32 times by negative 2. So that's 16 minus 64. So negative 48. So hence the stationary point is negative 2, negative 48. So just a little bit awkward. We've got lots of negatives there. So just keep a watch out for what's going on when you're using those values. Moving on. Find the coordinates. Oh, determine whether this is stationary point is a max or a min. So should I call that part A? This part B. I need to find d2y by dx squared. d2y dx squared. So if I look up to this here, I'm differentiating that again. 4 3s are 12. So it's just 4x squared. When x equals negative 2, substituting that in, d2y by dx squared is equal to 12 multiplied by negative 2 squared. That's positive, clearly. It'll be 12 multiplied by 4, so that's 48. And that is greater than 0, hence minus 2 minus 48 is a minimum. And then this, often people don't like these questions, but you just need to think, maybe do a sketch as well. What does this mean? What is going on here? So I know that this curve has got a minimum at -2, -48. So -2, -48, obviously x and y axes aren't the same scale. So I'll just represent it like this. You, of course, just can sketch this on your graphical. A quartic equation is similar to a quadratic. When does it increase? Well, this is the minimum, -48 and -2. I can see that it increases for this section of the graph here because it's just going up. It is increasing, isn't it? So the point at which it's increasing is determined by where that stationary point is. So I know that's just the curve increases for values of x being greater than -2. So technically we shouldn't put greater than or equals, because when x equals -2, that's when we've got our stationary point. So we should make sure we put a strictly greater than sign there. Okay, right, so this one here looks very much shorter, doesn't mention anything about finding stationary points, but it does tell us to find dy dx, so let's just get stuck in. 2x plus 3. So find dy dx and then hence find the values of y for which it's increasing. So if it was just, if it didn't have that hence there, you'd possibly be thinking, all right, well, what's going on? What would I do there? I would just always, every single time, encourage you to draw a graph. This cuts through at 0 and -3. So, oops, it looks like that. Sorry, very wobbly. And now, a bit like the previous question, I can see it's increasing here. But the crucial part is, if you find where the stationary point is, then that tells you the point at which it starts to increasing. So find the stationary point. And of course, we do that by setting 2x plus 3 is equal to 0. X is equal to -3/2. So that point there is our -3/2. So I can say that y increases, or x is greater than -3/2. Finally, we have got a decreasing function, similar idea. Here you can see it doesn't mention anything about finding stationary points, doesn't even mention that we need to find dy dx. So you can see, in this little section, we've gone from just finding a stationary point, that first question, question 8, and then finding the stationary point, determining whether it's a max or min, and then talking about increasing. A little bit less information, question 10, and then question 11, we're not given at all. Sorry. Here. So we have kind of built up for this, and we know what we're doing. We know we're finding dy dx. If it hadn't been for all those previous things, sketching the graph, sketching it, drawing it on your calculator should then get us thinking, oh, hang on, those turning points are the crucial bits, the stationary points. So I think I've differentiated that correctly. Yeah, 3x squared, 36x plus 60. So always write down what you're doing. So I know I'm getting the stationary point when dy dx is equal to 0. So if I look at 3x squared plus 36x plus 60 equals 0, divide through by 3, which I can undo. Don't divide through by any x's, but of course I can divide through just by a constant. Does that factorize? Oh yes, of course it does. 10 and 2. X plus 2, x plus 10 is equal to 0. So x is negative 2 and x is negative 10. So what this tells us is that we've actually got 2 stationary points. Now it doesn't actually ask us to find the stationary points, does it? We just want to find the values of x for which f of x decreases. So we could put negative 2 into there, work out the y value, but we don't need to. Certainly a sketch would help. I know I've got 2 turning points. I know I've got one at negative 2, and I know I've got one at negative 10. We could find d2y by dx squared, and that will tell us which is the max and which is the min. So if we quickly differentiate 6x plus 36, when x is negative 2, I would get 6 times by negative 2 plus 36. That is greater than 0, so I've got a minimum. And when x is negative 10, I'm going to have 6 times by negative 10 plus 36. That's less than 0, so I've got a max. But again, because it doesn't say I need to find d2y by dx squared, and because you all know, we know what cubics do, that's a positive cubic. So actually, aimed with just where the turning points happen, you should be able to sketch it. And in fact, you probably noticed as well that we could kind of factorize out a value of x. Sorry, I don't know why my pen sometimes randomly just goes fat. I can see there that there is a root at 0, so I also actually know it goes through there. But because it's a positive cubic, I know it's going to finish up going up through there. Oh, and that's not working because I'm between pages, aren't I? So I knew, come on, graph, come back. Okay, am I back? All kinds of odd things deleted there, didn't it? So because it's a positive cubic, I know it's going to end up here. So I can sketch it. Come on, let me sketch it, please. It would look something like that. And you know, this confirmed it anyway, didn't it? That I had a minimum when x is negative 2 and a maximum negative 10. What the actual question wanted me to do was to state the values for which it was a decreasing function, and we can see that it's decreasing. When is it getting smaller? It's decreasing from that turning point there all the way down there, and then at this stationary point there, that is when it turns around and starts going back up. So I can see from the graph, but you'd also be able to, I suppose, work it out from here, but I'd want a backup there. You want to see the graph so you know what's going on. So I know that the graph decreases, or it's called fx. So fx is a decreasing function. So between 10 and negative 2. So negative 10 is less than x, which is negative 2. Okay, Thank you. I'll see you in the next video for first principles. Let's stop recording.